A small cohort of Australian universities are supporting a homegrown startup exploring food production potential on the moon. Lunaria One is aiming to grow plants on the moon in as little as 3 years' time, bolstering food security and sustainability. I caught up with Associate Professor Caitlin Byrt from ANU's School of Biology and Institute of Space and a science advisor to the project. I started by asking her what sort of plants she's hoping to grow on the moon. Caitlin, thank you very much for joining us. What sort of plants are you hoping to grow on the moon?
Well, this challenge is both a scientific challenge, an engineering challenge, and a biological challenge. We need to pick plants that can survive the extremes of space travel and then be able to grow when they're in a contained environment right on the surface of the moon. And we're looking at plants that have evolved really extraordinary mechanisms. So there's a type of plants that are called resurrection plants, and they can dry down to a very small proportion of their normal water content and stay in that state for a long period of time. And then upon rewatering, they can come back to life. So we're interested in that as a mechanism because that type of capability to go into like a stasis mode is compatible with long space travel. There's even some Australian types of resurrection species that we're exploring to understand what sort of plant species will work best when we're doing these early steps of growing plants on the moon.
This is such a fascinating project. You mentioned the difference in conditions. So how different will it be, do you think, growing plants in space versus how we grow plants here on Earth?
Well, the encouraging thing is that the high temperature extremes, the freezing extremes, these types of extremes do actually occur on places on Earth, and plants have adapted to all kinds of extraordinary extremes. So one of the challenges will be that how do we learn from the plants that have evolved in these sort of extreme environments on Earth and then build and design plants for space travel? So the area of synthetic biology, which is like designing biology, is booming, and there's great scope to be able to design an entirely new plant that is adapted for space travel.
How do you hope this will increase our knowledge when it comes to food security and sustainability?
Well, we are facing so many challenges for food security here on Earth. We've had a long period of time for humanity where we've had a stable climate which is compatible with production of huge volumes of food. Now we're entering a period where we're getting more extreme weather, and that is really problematic for sustaining crop yields. If we can understand some of the really essential parts that are needed to be able to look after plant growth, then we can better engineer crops that will be key for our future food security. And similarly, the engineering challenge of creating a controlled, protected environment for plants to grow on the surface of the moon, that knowledge can be spun off into applications of how you design systems for food security on Earth. So if you imagine after things like the Hunga Tonga eruption, or after things like the Hurricane Ian, where you've had an extremely disruptive event, we might be able to support communities with food drops. But then after that, how do they rebuild? So if you have the type of systems that you can use to protect plants and rapidly propagate healthy and nutritious food, then that can be a huge advantage to supporting communities that have been impacted by climate disasters. So we really need to learn and think outside the box at how we can create these kind of systems to provide food security in the future.
As you said, this would be a huge advantage in the future for a number of communities. So it's such an exciting project. What's the deadline? Have you got an idea of when you would like to achieve this by?
So we want to be ready to go for 2024. So we have a little bit more time to trial all our systems and get everything ready, and we'll aim for 2024.